Hello viewers, I am Dr. N. Srinivasan from Congo Engineering College, Perundurai. Topic of the day is types of nanomaterials. Types of nanostructures. So we see bulk material is a material in all the dimensions macroscopic range. Size of the bulk material in all the dimensions in macroscopic range. So nanomaterials or nanostructures can be classified into three. So we have three dimensions, X, Y, Z. These are the three dimensions. So there are three possibilities. First one is one dimension, size of one dimension is reduced to nano. Other two dimensions are in macroscopic range. So this kind of nanostructure is called as one-dimensional nanostructure. One-dimensional nanostructure is a structure with at least one size of one dimension is reduced to nano. Other two dimensions are in normal range. So one-dimensional nanostructure example is thin film. So thin film is a one-dimensional nanostructure. This is otherwise called as quantum well. So quantum well or one-dimensional nanostructure. Example, thin film. Let us move on to the second type, that is two-dimensional nanostructures. Two-dimensional nanostructures are nanotubes. They are simply called as nanotube. So now we are able to understand here the size of any two dimensions are reduced to below 100 nanometer. One dimension is in the macroscopic range. So it is called as quantum wire also. Two-dimensional nanostructure, nanotube, quantum wire are the nanostructures with at least two dimensions are reduced to below 100 nanometer and one dimension is in the macroscopic range. That is, size of one dimension is in the macroscopic range. Example, carbon nanotube, quantum wires, that is nano wires. They are an example of two-dimensional nanostructures. Three-dimensional nanostructure or quantum dot. All the three dimensions of a material, size of all the three dimensions of a material is reduced to below 100 nanometer. then that is called three-dimensional nanostructures. Simply quantum dot. So quantum dot is a three-dimensional nanostructure. One-dimensional nanostructure, thin film. Two-dimensional nanostructure, nanotube. Three-dimensional nanostructure, quantum dot. Otherwise, we can classify this kind of structures into quantum well, nanotube, quantum wire or quantum wire, quantum well, quantum wire, quantum dot. One-dimensional nanostructure, two-dimensional nanostructure, three-dimensional nanostructure. Quantum well, quantum wire, quantum dot. So generally we have in nano science bulk material and nanomaterial. So bulk material is a material in which all the three dimensions are in macroscopic range. Nanomaterial is a material at least one size of one dimension is reduced below 100 nanometer. So nanomaterials can be classified into one-dimensional nanomaterials, two-dimensional nanomaterials, three-dimensional nanomaterials. The same can be classified, you can say, as quantum well, quantum wire, quantum dot. The example of a quantum well is thin film. So thin film is a nanostructure. It is called as quantum well. Carbon nanotube is a nanostructure. It is called as in the quantum wire category. Quantum dot. So in quantum dot, all the three dimensions, size of all the three dimensions are reduced to below 100 nanometer. So once again you just keep this statement in your mind. Nanoscale is the scale in which 1 nanometer to 100 nanometer is there. So nano range is 1 to 100 nanometer. 1 nanometer to 100 nanometer is called nano range. So let us quickly revise what we have discussed. Bulk material, that is known by you. Nanomaterial, at least size of at least one dimension is reduced below 100 nanometer. Why it is below 100 nanometer? 100 nanometer represents nano range. 1 nanometer to 100 nanometer represents nano range. So quantum well, quantum wire, quantum dot. Thin film is a one-dimensional nanostructure. Carbon nanotube, it's a two-dimensional nanostructure. Quantum dot is the three-dimensional nanostructure. So these are the informations what we have discussed here. So be happy, spread happiness to the society. Thank you. See you. Bye bye. See you in the next video. So I hope the informations are useful to you to understand about different nanostructures. Is it right? Okay. Bye bye.